Hello everyone, my name is Facundo and today we will talk about incremental static regeneration. First of all, I want to introduce myself. As I said, my name is Facundo Giuliani. I'm from Buenos Aires, Argentina. I work as a developer relations engineer at Storyblock. I'm also an Auth0 ambassador, Prisma ambassador, and Cloudinary media developer expert. If you want to talk about any of these products or anything, you can write me. My website is fgiuliani.com and I'm on Twitter as Facundo Zurdo. So first of all, I wanted to define what a static web page is. It's a web page that is delivered to the user's browser exactly as stored. So we can have a web page that is conformed by HTML file, CSS file, and JavaScript file, and that will be considered a static page. That doesn't mean that the content of the page will be static, but we will be delivering the same files to all the users that visit our website. And that is the difference with a dynamic web page, where it's a web page where some of the content is generated dynamically when needed. We can generate on the fly HTML content that we will deliver to the user that is visiting our website, depending, I don't know, any condition or any logic that we have and we execute in our web servers. We have different ways of generating this dynamic content. One of these ways is using server-side rendering, where the HTML content that is generated dynamically, it's done in the web server. So the web server will be the one that will generate the HTML content and will deliver to the user a web page that will look like a static page, but on the fly it was the HTML content or part of the HTML content was generated. On the other hand, the client-side rendering is when the HTML content is rendered directly in the browser using JavaScript. This would be like the common use case for React, where the HTML content that we generate or the markup that we generate is based on the components that we have in our application and, well, any other single page application that we can create using React or other JavaScript frameworks. But let's go back to the static web page, because if we analyze them, we can see that we have different benefits that the static web pages offer. For instance, the static web pages are fast because we are just delivering files that are stored in a web server as they are stored. So we don't have to do any logic to generate the content that we want to deliver. They are cheap because we are just storing files like any other file system. They are easier to maintain because these files that we create, I don't know, probably writing the content in a text editor or something like that, using the method that we want. We can move one file from one place to the other. We can deploy new versions of our website, like just moving the new files to the web server and etc. They are secure because we are not executing any code in each request that we receive, so we don't have to worry about the security of any code that is executed because there's no code being executed. And it's easier to scale because we can add storage space to our web server, and that will be enough to get more files and create more pages for our website. And it's stable because as we are not doing any calculation or processing on every request, we are just delivering files, and that will be more stable for our website. So having these benefits in mind from the static web pages that were created, I don't know, at the beginning of the 90s, for instance, with the latest frameworks and tools that were developed in the latest years, a new concept appeared, the concept of static site generation, which is compiling and rendering a web application at build time, generating static assets like HTML, JavaScript, and CSS files. So we will have different data sources, content, template engines, databases, APIs, third-party services, and we can generate the logic that will create the HTML content for our website, and we will use a static site generator to run a build process for our project and generate static assets that will be our website. So these static assets that we will deploy to the web server later are generated when we run a build process with the static site generator, and all the dynamic content that we generate using the different processing and data sources that we have will be analyzed and let's say rendered at build time. So we can be sure that when the users visit our website, they will be seeing static assets, static pages. And I mean, that is using the benefits of the static sites, but using frameworks and tools from the latest years. There are several static site generators. Today, I will focus on Next.js, which is a React framework that allows us to create user interfaces, static pages, and server-side rendered pages. So we can work at the page-based level, let's say. I mean, we can create JavaScript files for each page that we will have in our website, or we can create dynamic routes that will generate different pages that follow a certain criteria or certain URL, let's say. And we can use per page level or differentiating each page how we want to render the content for it. So we can have static site generation for some of the pages in our website. Let's say that we have, for instance, a blog. We can use static site generator to generate the home of our blog, and then one page per article or per blog post, let's say. As the content that we will expose in our blog post will be always the same, and for all the visitors of our website, we can generate them ahead of time and in a build time, generate static pages and static assets that we will deploy to the web server, and they will be available to be visited by our visitors. But we can also have, I don't know, dynamic pages in our platform or our website. And we can use server-side rendering in those cases, or client-side rendering, depending on what we need. I mean, client-side rendering would be like the regular React, but we can use server-side rendering too. So the server returns a page with dynamic HTML content that was created on the fly, but on the server. We can also have API routes in Next.js to execute code like the serverless functions do. So they can return, we can consume services or APIs using API routes. And one of the other cool features that Next.js has is that we will have fast refresh on developed environment. So if we are using, for instance, static site generation, that doesn't mean that whenever we apply a change on the content or the code of our website, we will have to run the build process again. The code will be changed, for instance, and the changes will appear automatically on our browser while we are working locally. So we see that we can create static sites, but using new tools and different data sources and template engines and etc. Everything at build time. So again, going back to the same example, we can create a blog post, a blog site with a lot of blog posts, rendering all the content that we need ahead of time and deploying static assets. But this have a problem because when we start creating more and more articles and blog posts and etc., and our website gets bigger and bigger, the amount of time that we will need to generate all the static assets at build time will be bigger too. So if we are working, I don't know, for instance, in an e-commerce platform where we sell products and we start adding new products and changing the description of the products and, I don't know, changing the price of the products, if we want to generate all the pages for all the products again, and we have to run a build process, the time will increase and will be super big, and probably that doesn't help us or doesn't work for the scenario that we are trying to solve. There's a concept used with the static site generators that is the atomic deployment. That means that when we run the build process, we have to generate all the static assets for our website. If there's any error while executing this build process, or if there's any page that we are not generating, we say that we are breaking this atomic deployment, because we will have different versions of the pages living in our website, and that's something that we don't want. I mean, we want to have in sync all the pages, and like we say that all the pages that we are exposing in our website are from one version, let's say. But well, I mean, the build time increasing is a problem. So Next.js team analyzed that and created a new feature for the framework, which is incremental static regeneration, which enables the developers to use a static generation, but on a per-page basis, without having to rebuild the entire site. This feature works like this. We will execute this build process one time. We will generate all the static assets or all the static pages, or probably a limit set of pages. In a blog site would be probably the latest 5 blog posts and the homepage, let's say. And we will cache the version, this version 1 of the pages, and we will set the value for the revalidate property, which is revalidate. And we will set an amount of seconds that will happen between the first time that the users visit this version 1 of the page and when this revalidate time expired. What the framework is going to do is, for the next user that visits our website, we will display the cached version of the page. But in the background, a build process will be executed just for that page. And we will generate the new version of that page that will be created the static page, stored in the web server, and cached. So the next users that visit our website will be seeing this version 2 of the page. This is helpful because we will have faster builds, because we will be generating less static assets at build time, and we will have a higher cache because of this, because in the meantime we will be generating new versions of the page and we will keep that cached. This helps also to work with headless content management systems or different content systems that we can use to generate the content that we will display in our website. Because if a change is applied to the content of our website, let's say the same example as the blog post. If we have a typo or we are changing some content for a blog post, the next time that the user visits that blog post or the page for that article, we will use incremental static regeneration to generate a new version of the page and display that to all the other users that visit our website. And these pages will persist between deployments. So if we want to deploy a new version of our website because, I don't know, we did a lot of changes to the code or anything, the pages that were generated using incremental static regeneration will persist there. Which is cool, but also we have the problem that we are breaking the atomic deployment, the concept that we mentioned before. Let's see a quick demo of how this works. I have this website with a title and a grid of features, let's say, and I will use the 3 different methods to generate a page that we mentioned: server-side rendering, static site generation, and incremental static regeneration. So I'm running this page with server-side rendering. We will always generate on the fly the content, so the content will be always up to date, because we are running it for every request. If I use static site generation, we will always see the same page because it was generated at build time. And if we use incremental static regeneration, we will see the page that was created at build time, the static page. But if we do a change, we will see that change for the next visitors after we apply that, because we will run this build process again just for this page. So if we go to the code of my website, I won't stop on explaining the hierarchy of folders and files that Next.js create for a project, but we will have a folder page called pages, and inside of it we have the 3 URLs that I visit with the dynamic routes that I mentioned before. and depending on the slug, which page we will display. We will have a main function that we will use to render the HTML content for our page using components here like React components. I have a layout and a page, and we use the content that we bring from an API, which is an API calling of a headless CMS that I'm using to maintain the content for my website. The headless content management system that I'm using is Storyblock. We are using the Storyblock client to get the information for a certain page or a certain story, let's say, and with the data that we are bringing from the API, we are returning that as a property, as a story, to the main function that will render all the markup for our page. If you see here, I'm like hard coding the slug or the URL for a page because this is the only page that I have in my site. And this get server side props is a method that will be executed for every visitor that comes to our website. If we go to this example, which is the static site generation, the main function is exactly the same. We have a very, very similar function called getStaticProps, which executes the same and brings the information and returns that to the main function to generate the markup. But as we need to define which pages are we going to render at build time, we have this other function called getStaticPaths with the logic to generate all the URLs or all the pages that we want to render at build time. As we have only one page in our website, which is the slug home, we are returning a JSON object with the property paths and only that item that will be used in getStaticProps to get those params and use the slug that we are sending to generate the markup for that page. If we have more than one path, we will have a list of paths here that we are returning, and we are rendering the content for each one of those paths. And on the example of incremental static regeneration, the code is very similar to the one that we just saw. I mean, the main function we have getStaticProps too, because we are generating the pages at build time, and getStaticPaths because we want to generate this home page at build time too. But we are changing this fallback to blocking because we want to generate the markup for the page in the background if we set a revalidate value, which is here and which is 10 seconds. This means that if a user visits our website after 10 seconds from the first time that we display the page, in the background we will run a build process for this page to generate the new markup if there was any change. And that is the example that I want to show here. We will apply the change to the content and see how it works for each type of rendering. This is the real-time visual editor that we have for Storyblock, which is connected to my local host. So what I would do is go here and apply a change. We can apply this change here. The feature one will be called now feature test. And I will save the change here. You can see that I can see the changes even if I don't save or apply the changes to the information. That is one feature of the real-time visual editor of Storyblock. But now let's go to our real site, let's say. So I will see what's happening with server-side rendering, which is after loading the page, we see the feature test. Which is correct, because for every visitor, we are generating the dynamic content on the fly, and we are displaying the updated content for each visitor. But if I go to static site generation, what I will see is the previous version, because we created this page at build time, and we didn't execute any build process again. So we are displaying the static page that we generate at first, and we can see the updated content. Lastly, if we see the incremental static regeneration example, what we will see is again the static page that we generate at build time, but in the background we should be executing this build process to generate a new version of the page for the next visitors that will come to our website. So if I refresh the page, what I will see is the updated content, and we have this version 2 of the page for all the visitors that will come to our website. And well, we are using the feature incremental static regeneration here. So if you want to learn more about this, you can go to Next.js official website. They have an e-commerce demo, which is an e-commerce platform using incremental static regeneration to probably understand better how the concept works, or probably seeing a more complex example. Or if you don't know Next.js or you want to learn more about it, they have a very cool learning platform that you can visit also in their official website. So thank you very much. I hope you enjoyed this presentation and see you soon. Bye.